Hi, good day, everyone. So we're going to focus on starting with our log functions today. And we're going to start talking about how does a log compare to an exponential and kind of how do they relate back to how do they relate to each other in the first place? Okay, that's kind of the key thing we're going to be talking about. On top of that, I hope a lot of this is review for you because we did do logs last year in Algebra 2. And we talked about how things actually align with certain values, how we flip those things around. Hopefully a lot of this is kind of like a recall to some of that information, okay? But without further ado, let's go ahead and get started. So we're going to jump pretty far off the bat. Okay, we want to go right to this portion here. We start talking about the logarithmic functions. Okay. The key thing I want you to understand is first and foremost, understand that these values are related to one another. Okay, so we're going to start by graphing these two values here. Okay, a log function as well as an exponential function as shown on the screen right now. Okay, and we want to compare both of these values to one another. So particularly, we got to throw some numbers in there. So we're going to do y equals 10x, and I'll do that in the color black. And then in the color blue, we'll do y equals log of x. Okay? Well, if I graph out y equals 10 of x, at 0, we're going to have a value of 1. And at 1, we're going to have a value of 10. So my graph is going to look similar to this. Okay? If I plug in log of x, that value is going to be at x equals 1, we're going to have an answer of 0. And at 10, we're going to have an answer of 1. So we're going to look at a value. Oops, promised I would do this in a different color. Let me fix that for you. Value of 1, value of 10. And our graph's going to look similar to this. Okay? And so what we have here is two different functions, an exponential and a logarithmic. The one thing I want you to notice is how similar these really are. Okay? On top of the fact that we got to kind of start talking about something called an inverse. Okay, because these two are inverses of one another. Okay, one of the key ways I always look at this is that look at our actual coordinates. Our coordinate here at this point is going to be 0, 1. And at this coordinate, we have 1, 0. You see how they're exact opposites, or we have our x and y values flipped? And this is going to continue throughout the whole chart. Notice at this coordinate, we have 1, 10. And at this coordinate, we have 10, 1. Okay? These each are inverses of one another. The log function is the inverse of an exponential. Particularly, these two are inverses because they both have a log base of 10. Okay, excuse me, they each have a base of 10. We have a log base 10 and we have a base of 10 exponential. Okay? Now, in the letter B here, they say the functions log of x and y equals x are inverses. How does the graph support this statement? Well, inverse functions always have this very interesting thing about them in the fact that they always are my bad, symmetrical with the equation y equals x. They're always symmetrical with the equation y equals x. Okay? So if I look at this function here and I actually work this out, these two could be flipped over that dotted line right there. And the fact that really all we're doing and the reason why this works is we're flipping the y and x values, which gives us the whole graph itself, y equals x. Because if I were to flip those values, I would get the opposite coordinate point. Okay? So if I want to support this statement, then they have symmetry over y equals x, which basically is the definition of an inverse function in the first place. Okay? Next thing I want to talk about down here is the domain and range of log of x versus the exponential. Okay? To kind of quickly review this, domain is always the x value restrictions. Range is going to be your y value restrictions. Okay? Or in other words, it's basically going to be your independent, dependent, what you can plug in, what you can get out. All those things work with the domain and range. So I look at the domain and range of log of x. Okay? My blue graph, my blue graph there. The big thing I want you to think about is the fact that I never cross my y-axis here. Okay? On top of it, we can't really have a negative value in there. Okay? It wouldn't make sense. So for my domain and range, my domain, actually, I'll just make this a little bit shorter. I'll just write the letter D there. My domain is going to go from the interval 0 to infinity, while my range, I can have any values below and any values above, meaning my y values have no restrictions. So my range is just negative infinity to infinity. Versus in the other equation, they're asking what is the domain and range of y equals 10 to the x? Well, here's the next thing we got to think about. Even though I drew this graph poorly, this line should never cross this axis here. Because if you think about it, if you were to plug a negative exponent into this value, it's going to become not a negative number, but instead it's going to become a very low decimal. So I can never get a negative value or a negative answer out of that graph. So that tells me that while my domain is going to be negative infinity to infinity, my range is restricted to 0 is the lowest value I can get to or try to get to because I'll never actually reach it. But I can still go up to infinity, okay? Now, the key thing here that you have to understand is that these also help represent an inverse function, simply because the domain and range are flipped, okay? You can clearly see that your range and domain both flip in this scenario, okay? Describing once again how, since domain represents the x and range represents the y, that we literally flip those values. So with that being said, let's kind of explore log and the natural log functions. Okay. So in this function here, we have log of x and we have ln of x. And what we really want to do is try to assume, like, what is our answer going to come out to be in each of these, okay? The first thing I want you to think about is that this value here is what we call a natural log, okay? It's a natural logarithm in which, if you notice this line up here, a natural log goes with the function e to the y equals x, okay? Versus a log function, like this one, since I'm not given a base, we consider this to be a log base 10. Oops, I won't write x. This is considered to be a log base 10. So when we consider this, if I plug 1 into that original function, my y value is 0. Okay? Here's the whole idea of both of these. This is kind of the key thing I want you to think about. The reason I'm getting a 0 as an answer is because we want to think what exponential value would give me an answer of 1. Okay? If I were to think about just the equation y equals 10 to the x, well, if I were to plug a 0 in for that exponent, y equals 10 to the 0, my answer would just come out to be 1. So what log is doing is giving us this value of an exponent. It's actually telling us what is the exponent as an answer, okay? So when I plug 1 into a log, I'm basically asking, what is my exponent that would give me an answer of 1? Same thing here. If I had an answer of 10 here, my answer would just be 1 for each of these. Or if I had plugged in a 10 for each of those x values, my answer would just be a 1. And it's the whole same idea here. It's using this idea of what exponent would give me a 10. Well, if I had 10 to the x, if I plugged a 1 in for that exponent, my answer would be 10. So if you notice, this is one of the key reasons why we are getting that as a specific answer. Okay, because our log is going to give us the exponent as our actual value for an answer. Now, if we continue this on, you should notice this throughout the rest of the problem, where if I have 10 to the second, my answer is 2. 10 to the fifth, my answer is 5. If I use a natural log with a value of e in it, same instance occurs. Okay? And that's kind of the first key thing I want you to think about. Log and natural log, what they're going to give us is the exponent for that value. Okay, that is going to be the actual answer or outcome out of that problem. So let's just talk about log properties. Okay, if anytime I plug in a value of 1, my answer is going to be 0. Okay, because anytime you have to get a value of 1, you need an exponent of 0. If my bases match, well then every time my answer just has to be 1 because there was no change from my base to my inputted value. If I am given a base with that same base of an exponent, my answer is just x. Okay? Because whatever the exponent was has to be the answer. Same thing over here, exponential form. All three of those would just be rewritten exactly as they are in the exponents. Okay, but as you can kind of notice how the values kind of match up. Okay? Same thing down here. ln of 1 would be 0, ln of b would be 1, and this would be x, while these values would all be written pretty similar to the same way. Okay? Notice how it matches up from what we are inputting to our answer. Okay? We input a 1 into the log, we get an answer of 0. We input a b into the log, and we get an answer of 1. Okay? So in number 11, we're basically going to solve or use these ideas to help solve our log properties. And this is how we're going to kind of work it out. Log base 3 of 27. Our goal for this one is to kind of think of this in a couple different ways. Okay? Log base 3 of 27 can be rewritten as an exponential function like so. We have our base, which is 3. We're trying to find the exponent x, and that's going to be equal to 27. So if you notice, if I want to write it as an exponential, we have a base, our exponent, and our answer. And from there, all we have to do is plug a value in for x, or try to think 3 to what power is going to give us 27. Well, in this case, x has to be 3. Same thing here. If I want to do letter b, we have a log base 4 for 2. This is going to be our base, which is 4, to the power of x equals 2. Well, in this case, this has to be x is going to be a value of 1/2. Okay, so we can clearly turn a log back into an exponential to help us solve it out. Okay. We'll go over the rest of this in class tomorrow, but that's kind of the basics of log. We'll go over kind of this more in depth and talk about how to move values around. Besides that, answer the questions in the Ed puzzle, and we'll talk more moving forward. Have a great day.